Hi sir, good morning.
Good morning.
Hi sir, my name is Umeysh. We spoke on the phone earlier.
Okay. Nice. Nice to meet
Uh, just meeting you too, sir. Am I clear or am I breaking off?
you. No, no, clear. Loud and
Okay. Alright, sir. So please feel free to inform me if I'm breaking off or I didn't speak clearly.
clear. Sure.
So, so as I explained before, sir, the purpose of us conducting this interview is because of our thermodynamic subject group assignment. So we are actually assigned to call out and interview someone to understand how they use the thermodynamic system in their processing factory or power plant.
Okay.
Alright, I will be starting up the first. Okay, sir. So we are doing the steam turbine, yes?
I think we take. Is it okay to take a boiler?
Sure, sure, no problem.
Okay. Because so many information I want to share with the boiler.
Alright. So first we'll be focusing on the boiler.
Yep.
So sir, the first question is, what is your company's main business and the industrial production, which is the background of the company?
Okay. My company is founded by Untitled Chapter in 1906. 100-year company. Started with rubber. Later they changed the crop to oil palm. Okay, we are planting oil palm, cultivating oil palm, planting, harvesting FFB, and processing at our mill. We took over a mill in Kumaar, Pahang, 2004 from Tombi, Malacca. That mill's capacity is 35 metric ton of FFB per hour processing capacity. Okay, currently the mill can process 150 to 180,000 per year FFB, where we are processing 70% of our own crop and 30% outside crop. 2014, we have put up an mill in Sabah, Sugut, Sugut area, 45 ton mill, which is capable to uh, process under 60 to under 90,000 per year. Yes. Where same scenario 70-30, 70 internal crop and 30 external crop. And in 2019, we bought a property in Indonesia, Kalimantan Tengah, if I'm not mistaken, 2014. Planted poppy, oil palm, and put up a mill and commissioned the mill 2019 June. The mill is capable to process 60 ton per hour, which is currently processing around 180 to 190 metric ton FFB per year. There, the scenario is 80% internal, 20% external crop. This is the brief introduction, and our HQ is at Melaka, Melaka, Melaka town itself.
Yes.
That is the
So,
brief introduction of my company.
alright. The
And
producing
you want,
180.
excuse me, you want any detail, you can go to the United Malacca web page. You will have detail history of the company.
Alright. So, you also say that producing the 182 metric ton a year is actually one of the things that make your company outshine the others or stand out from the others.
Not to say that they are much bigger player. We are only a small company. Okay, there are the company can they, even you put 3 meals or 30 meals uh, production capacity for annual 180 times 3. is only 540,000 per year. There are the company can process 2 million, 3 million tons of FAB per year. That means you know the quantum lah, where we are standing. Not small player, not big player, between that.
I see.
Okay.
All right. All right. Thank you, sir. So next, my friend will be asking the question. So we will be taking turns to actually ask the question among us.
No problem.
All right.
So,
Sathesh, you're up. Thank you.
hello, sir. So the second question is, what is the function of boiler system, and what are the types of boiler used in your company, sir?
Okay. Basically for the palm oil mill processing, I'm just give a brief history where previously we used to use fire boilers. That means you should know the difference between the fire tube and water tube boiler. Fire tube boiler where the fire is inside the tube and heating up the water. Same like our electrical kettle lah, because the coil is inside to the tube and heating up the water external. Where the other water tube boiler is where the water is inside the tube and heating element or heating the surface is outside the tube. Other way around. Okay, we started with the fire tube boiler. Later for the palm oil processing, the steam demand, because what fire tube boiler cannot cater the steam demand. Later, we switched to water tube boiler in order to accommodate and to cater the steam fluctuation demand in our processing. Okay, currently, normally now every palm oil industry using water tube boiler by drum. That means you will have a steam drum and mud drum. You have a series of tubes, which is a connecting mud drum, aider, and a steam drum. The process which is taking place in palm oil mill, when you process, you will be having a waste. The waste is being used as the fuel to heat up water, to convert water to steam in the boiler. Steam being used in a steam turbine to generate electrical power. We're having a boiler which is capable to produce steam 35 metric ton per hour in both plants. Okay. Model of the boiler which is we are using is depends. So in our place we are using a Vickers water tube boiler and a Boilermatic water tube boiler. That is basically called brand. There are a few other brand, Macmar, Advanced Boiler, Takuma, so many things.
Hello, sir. Can I ask why that particular model is used?
In that particular time, we will compare. Normally, you want to buy a car, also we will compare, right?
Yes.
Okay. I might like Mercedes. You might like BMW. It's a very tough question to answer. It depends who is selecting the boiler.
All right.
Each and every boiler will perform in the way it's designed, and it depends. Every car can travel 200 km per hour, right? But to explain why you prefer Mercedes compared to BMW is a very tough question to answer. Okay.
Okay, sir. Thank you, sir.
All the boiler in the market capable to produce what it's supposed to be designed to produce.
Right.
Yeah. Anything else on the second question?
I think that's all, sir. So now we'll be moving on to the third question.
who will take turns to ask?
Yes, sir. Yes.
Okay.
Can you hear me?
Can loud and clear.
For that, my name is Srikoohen. Very nice meeting you, sir.
Yeah.
Okay, the third question for today is the design consideration taken account for boiler and steam pipe functionality. For example, sir, what kinds of material that you use, the testing stuff, sir.
Okay, no problem. Basically, when we want to strike the boiler, first you go for what is the requirement of your process, because the requirement of the uh, process demand determine what is the size of the boiler you need to put up. Okay, uh, that means for a rule of thumb, every metric ton of FAB to be processed in palm oil mill, you require to have 600 to 650 kg of steam. Okay, based on that, we will design the boiler. For your information, got awarded or gifted palm oil industry important gift to the industry. First, this is the formula. Normally, when we design, there is a detailed calculation. I don't want to discuss here. We take a very basic things, and we can use this rule of thumb to design a boiler and your first. Okay, when your process per metric ton of FAB, you will for example, easy calculation, I take it 100 ton metric ton of FAB. That means you will have 12 to 13 metric ton of a mesocup fiber. Okay, and you will have 5 to 6 ton of palm kernel shell. Okay, and you mix together mesocup fiber and palm kernel shell at the ratio of 70-30. That means in 1 kg of a fuel, 1 kg of a fuel, which is contains 70% of mesocup fiber, 30% of a palm kernel shell, okay, will give you 3.5 kg of a steam as long you maintain the feed water temperature at 70 degrees C. This is a rule from first equation. Okay. Second equation, to process 1 metric ton of FAB, I need 22 to 24 kilowatt electrical power. Okay, this is the second equation. Third equation, to generate 1 kilowatt of electrical power, you need 20 to 25 kg of steam at 21 bar. Just now the equation number 1, it will generate 3.5 kg of steam at 21 bar. I forgot to inform you. That means these three equation is got gifted to the palm oil industry. Then that means when you design a mill, 10 ton, 20 ton, 30 ton, 40 ton, 60 ton, 70 ton, 80 ton, 90 ton, 100 ton, 150 ton. That means follow the equation number 1, you will have a sufficient fuel. Sufficient fuel, you will have sufficient steam. Okay? After that, automatically, equation number 2 and number 3 falls in place. That's the beauty of God. Okay, that's a talks about the calculation, how we get a boiler. You can select whatever boiler you want it, whatever brand, but end of the day, this is a detailed calculation. Okay, because as you all know from the temperature enthalpy diagram, uh, to convert water to steam, you need sensible and latent heat, correct? Okay, for example, my feed water temperature 70. That means from 70, I want to bring the steam pressure 21. From the steam table for the 21 bar, you will have enthalpy for that, correct? That means to convert water at 70 to 213, if I'm not mistaken, 21 bar is 213.86 temperature, no, Celsius. That means you require roughly 228.35 kilocalorie kg of heat, or under 42.91 kilo kg heat. Okay. You go back to the fiber and a shell. When you burn the thing, you have a sufficient heat energy to convert one mass, 1 kg of water to 1 kg of a steam. From the the first equation, which is I mentioned earlier. Okay, the things boiler, no tubes. We use carbon steel, which flow standard 3059 part 1, where it is tube which is you should have a certificate from the manufacturer. We can't use it in any as a box, okay. And normally it's a thickness of 3.6 mm. And it's not a full extruded tube, it's a welded tube. That means the tube having a seam, it's not a seamless tube, where we are using a electrical resistant welding to weld the tube. Okay, it's a talks for steam. Normally outside the boiler, we will use API steam pipes, yeah. API, American Petroleum Institute standard schedule. Normally we will use schedule 80 seamless API steam pipes, and all the valves you have a specification. Either you normally for the PN20 for the boiler operating at 21 bar, normally we use a specification of a valve at the PN40, pressure nominal 40, to stand the pressures and temperature. Anything else? Okay, the boiler after it's been designed, constructed, testing will be normally we will use layout inspection authority. That means that one, whoever manufactured the boiler, they have to conduct the thing until the satisfactory of our Malaysian authority, Department of Occupational and Safety.
I think that's all for me. You can proceed to the next question.
Okay, thank you.
Good morning, sir. My name is Taranjit. Is my voice clear, sir?
Clear.
Right. Now I proceed to the next question. Sir, what is the thermodynamic principle that is involved during the combustion process in the boiler?
Okay. In the boiler, as I mentioned, the fuel previously, we having a two control system. Okay, first we control the fuel feeding system. That means whenever it required pressure, it will cut off the fuel. Okay. Second control system is our draft control system, because to maintain a good combustion, you should have a good air fuel ratio. We don't want in combustion have a more air or less air, which is will influence the combustion. Control that, we have tempers on induced draft fan and forced draft fan. Induced draft fan is to suck out all the combustion product. That means when you burn, there will be flue gases. To suck out that and to create natural draft inside combustion chamber. Okay, the forced draft fan to supply fresh air to combustion process. That means both these being controlled in a system where gives you maximum air fuel ratio, give you a good pressure. Okay, as what I mentioned previously, the energy required is being supplied by the fuel which is you are burning. To understand that, you can go to palm oil mill biomass. There, instead I am explaining to you. You can Google and check. Okay, from there they will speak about the mass balance of the fuel which is generated. What is the biomass? Mesocarp fuel, palm kernel shell, empty bunch fiber, and what is the energy content? All the things is you can get detailed things from that. Okay. Anything else?
Sir, do the boiler have any mechanism where you monitor the pressure inside?
Okay. For the pressure, it's important parameter to measure the things, because basically palm oil mill processing, for a good palm oil mill processing, there are two important things: steam pressure and temperature. Okay, if you fail one of these or both, won't have good processing. Okay, because the steam pressure determines the steam temperature. If you won't get the steam pressure, your temperature won't be there, and we are processing something. My duty is to extract oil. If temperature low, oil viscosity will be higher. It can't flow, and it will contribute to higher. One of the things is steam pressure. Second thing, feed water temperature. As what I mentioned, the first equation is F to ensure your feed water temperature at 70. If it goes below 70, that means your fuel consumption will be higher. You have to burn more to get more energy to convert 1 kg of water to 1 kg of steam. It's very simple. Okay. Feed water temperature. Other thing is flue gas temperature. That means we will measure what is the temperature the flue gas is going out. Normally, good 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 flue gas temperature between 250 Celsius to 300. Anything more than 300, that means the heat is not fully transferred the water to steam. That means wasting the heat. Might be your flue gas passes might be choked up, where the heat, instead of transferring to the water, it's going out to the atmosphere. That means you have to you're ending up putting a more fuel in it. That is one parameter which is very important parameter to monitor. Basically, when being a boiler operator, these is the three important things to be a monitor to ensure your boiler is giving a sufficient steam at rated fuel consumption.
That's all for this part of question. I will pass it to
Okay. Hi, sir. It's me again.
Yeah.
Okay, sir. So we're talking about the limited boiler system. We know there's no perfect system. So, what are the future technologies to improve the boiler system to overcome this limitation and to maximize efficiency and so on? Can you add on to that?
Okay. Simple as this. Diesel engine. Diesel engine will give you better thermal efficiency if equipped with a turbocharger. Correct? Okay. Turbocharger plus intercooler, you will have a more efficient. It's the same goes to the boiler. Normal boiler, water tube boiler, efficiency between 70 to 73. Okay. As what we have discussed previously, when you increase feed water temperature, you can reduce your fuel, right? That means I can introduce economizer. Economizer means you take the temperature from flue gas, you heat up the feed water before it's going inside the boiler. That is one, economizer. Other thing, it's like a diesel engine where turbocharger, you heat up the air which is going inside and pressurize the air which is going inside the combustion chamber, where in a boiler we can use a preheater. That means the air which is going to be pumped into the combustion chamber by the FD fan will heat up first. Okay, that is the second thing. And the third thing is on the superheated tubes. When we look at the temperature enthalpy diagram, right? There is a region, water region, liquid and gas mixture region. After that, you will have a saturated steam and a superheated steam. Okay, at same temperature, put up the steam to higher temperature. That means the steam will contain more enthalpy. Okay, by introducing superheated tubes. There are the industry palm oil already using this technology. It's not in our industry. It's already been there so long because now only we are putting in the place because the industry direction is moving towards more sustainability. That means how you save your resources. With the same resources, you improve the efficiency to get more power. Due to the industry moving forward, sustainability manner, now we already spend spend some monies to put economizer, preheater, superheaters. Okay. Anything else?
Uh, I'm so sorry to interrupt. Is there any potential where small industries of farm are using renewable energy sources as the future oil supply?
There are the technologies where currently empty bunch we are disposing at the field as mulching. You can convert the empty bunch, press, reduce the moisture, use the empty bunch fiber as fuel for your biomass boiler, and generate this steam and some electricity. That is one. Second thing, palm oil mean effluent, where there is a series of biological process to convert high BOD to lower BOD using a ponding system. When anaerobic process is taking place where the greenhouse gas being released to atmosphere, especially methane gas. Methane gas can be captured, used as combined heat and power. That means you can convert the thing to gas engine or gas turbine to produce electricity. Okay, sir. Okay.
We are done with the first set of questions, which are for the boilers.
Hmm.
Shall we take a short 5 minute break before we go to the steam?
Oh, steam turbine engine.
Sorry, yeah,
Yeah.
the steam
Okay.
turbine.
Okay, done.
All right, sir. Let's take a 5 minute break. Thank you.
Okay. Bye.